Welcome to This Explainer. Today we're diving into the true, often hidden cost of being a first responder. We're going to take a dense, landmark 2006 epidemiological study by Dr. Grace LeMasters and her team and translate it into the quantified, real-world cancer risks that our firefighters are facing every single day.
Think about it for a second. When you picture the absolute life or death stakes of a first responder's daily routine, what comes to mind first? Raging infernos? Collapsing roofs? Maybe massive explosions?
Well, contrary to what you might expect, the most insidious threat is not actually the fire itself. It's the lingering, invisible enemies they interact with long after the smoke clears. The data shows us that the real danger lies in what firefighters inhale and absorb while they're just trying to do their jobs.
Let's break down this threat beyond the flames, because firefighters are constantly bombarded by complex mixtures of toxins. At the actual fire scene, we're talking about particulates, heavy metals like cadmium and lead, asbestos, and nasty chemical gases. But you know what? The danger doesn't even stop when they get back to the station. Diesel exhaust can severely build up in those closed truck bays. During massive catastrophes, they're breathing in pulverized debris like cement from the World Trade Center. And then there's the direct physical contact. Plenty of firefighters report their skin being completely covered in a toxic black soot after a run.
Section 1. Building a super study.
So to figure out exactly how scientists proved these specific environmental exposures were causing cancer, we have to understand their method. Researchers couldn't just look at one group of firefighters in a single city. They built a meta-analysis, which is basically a rigorous super study. They dug through computerized databases and combined data from 32 different investigations, looking at the risk for 21 different types of cancer across thousands of workers. It is a massive undertaking.
Now, what I find really fascinating is how they objectively classified these risks into probable, possible, or unlikely categories. They definitely didn't just guess. They filtered all this data through a really strict three-step criteria. First, they looked at the pattern of meta-relative risk. Second, they evaluated the study type, actually downgrading the risk if the data came from less definitive study designs. And third, they tested for heterogeneity, meaning they checked to make sure the findings were consistent across all those combined studies. Only the absolute strongest evidence survived this gauntlet.
Section 2. The 4 probable suspects.
After running the data of thousands of first responders through that strict flowchart, 4 heavy-hitting probable cancer suspects emerged. And the most crucial point is this surprising number, 2.02. That is the summary risk estimate for testicular cancer. Just to put that into perspective, in epidemiology, a 1.0 means you have an average risk. So a 2.02 means the risk is literally doubled. This was the highest risk estimate of any cancer studied, which prompted scientists to officially upgrade testicular cancer to a probable risk for firefighters.
Next up, we have a 1.53 summary risk estimate for multiple myeloma. This was a big deal because it strongly confirmed earlier scientific suspicions from the 1990s that occupational exposures heavily influence this specific disease. Aside from race, there are essentially 0 known risk factors for multiple myeloma, other than things like paints, solvents, and engine exhausts, which, as we just discussed, are exactly the complex mixtures our first responders are working in.
Right behind that, there is a 1.51 risk estimate for non-Hodgkin lymphoma. And what makes this finding so compelling is just how consistent it was. This cancer showed an elevated risk across a huge diversity of study designs. Mortality, incidence, Ischia ratios, it didn't matter. No matter how the researchers sliced the data, the elevated risk for this lymphoma was undeniably present.
Rounding out the probable risks is a 1.28 estimate for prostate cancer. Now, prostate cancer is pretty common in the general population anyway, but this elevated risk is potentially linked directly to the specific occupational hazards firefighters face on the daily. We're talking about exposure to metallic dusts, pesticides, and diesel engine emissions inhaled right there on the job.
Section 3. Possible and unlikely risks.
This super study also confirmed possible links to skin cancer, malignant melanoma, and brain cancer. The skin risks likely stem directly from that black soot absorbing into the body that we talked about earlier. But I want to highlight the unlikely risks. The study found that larynx, bladder, and, incredibly, lung cancer were unlikely to be elevated. Now wait a second. Given the massive amounts of smoke firefighters inhale, finding lung cancer as an unlikely risk seems completely backwards, right? So why is that?
This brilliantly illustrates a concept epidemiologists call the healthy worker effect. Because firefighters have such strict physical entry requirements, they maintain high cardiovascular fitness and they have very low tobacco use compared to the general public. So, their super healthy lifestyles naturally suppress their respiratory cancer risks. It actually masks the intense, damaging effects of the smoke inhalation.
When we consolidate all this data, you can see exactly how the science isolates the occupational risks that specifically target our first responders. You've got those elevated numbers for multiple myeloma, lymphoma, and prostate cancer. You've got that massive 2.02 for testicular cancer, and right there at the bottom, lung cancer is sitting at a 1.03, which is essentially neutral compared to the general population. This data cuts right through our assumptions to reveal the true environmental impact of the job.
Section 4. Protecting our first responders.
At the end of the day, these summary risk estimates aren't just math on a page. They represent real people in our communities. As the researchers powerfully conclude, these findings are a massive red flag. The data absolutely demands that we innovate better, more comfortable protective gear. Think about it. If the gear isn't practical or comfortable, it's not going to be worn properly, leaving our first responders fully exposed to the soot, the diesel, and the heavy metals that we now definitively know cause these specific cancers.
I'm going to leave you with this final provocative thought for our explainer today. Knowing what the science now definitively proves about these invisible hazards, the diesel, the metals, the soot, how do we step up to protect the protectors? How do we ensure that the people who risk everything to save us aren't unknowingly sacrificing their own futures in the process? Thank you so much for joining me, and keep questioning the data.